Hi, period 4. It's Robert, and I decided to make this video because I think Mr. Nefrata didn't do a very good job explaining what we were supposed to be learning today in class. I think I understand it better now that I've been able to make some connections, and I hope if I do this one problem, I can make it easier for everyone to visualize it and make it easier for everyone to really understand it so we can do the homework quiz, which he never really talked to us about, and we can do the worksheets and we'll do well in the class later on. So I was able to really understand number 3 on the worksheet, which is on the back of the Unit 9 Diagrams for Water worksheet, number 3, the first one right here. It says, calculate the amount of energy released by 500 milliliters of water. The density of water is 1 gram per milligram as it cools from 50 degrees Celsius to 25 degrees Celsius. Now, the first thing I see here is that you're looking for the energy that was released by water. If we look at one of these phase diagrams, you can see that every time you have heat being added or energy being added, that's a change in the x-axis here. What you know from the problem is that water starts at a certain temperature, so you can plot it on the graph, and then it moves down to a lower temperature and to a lower state because it goes through one of these delta H changes. And so all you need to do is you need to take the stuff that you know, you take the mass and the temperature change, and you turn that into kinetic energy. It's like you know the y-axis, you know the change in temperature, and you need to find the change in heat. Now the reason Mr. Nefrata said that this problem has 3 steps is that you change phases, you change the steps in this graph 3 times. Once when you're going from a liquid to the melting point, to the freezing point. Another time when you're going from the freezing point all the way to when the water has frozen solid, in which there's no change in temperature, but still a change in kinetic energy. And the third time, when you're freezing the ice to make it even colder. You're slowing down the particles even more, and you're taking away more kinetic energy. So the first part, you can see here every one of these Q steam, delta H vapor, Q liquid, all of these correspond to one of the changes in this diagram. Q steam is this, delta H vapor is this. And the reason that delta H vapor and delta H fusion don't have any temperature changes is because there is no change in temperature. Literally, the line is flat here. The molecules are just gaining enough energy to spread out, and they're becoming another phase, or they're becoming a solid, they're becoming a liquid, they're becoming a gas. And that's why there's no change in temperature. And because of that, there's going to be no change, there's going to be no need to use any temperature in your calculations. In the problem, we need to find the Q, the change in liquid, the delta H fusion, and then the Q in solid. The first part, you know that the temperature is 50 degrees Celsius, and it moves down to 0 degrees Celsius when the water starts to freeze. So you can plug in MC delta T, and you'll get 500 milliliters, but then you have to convert that to grams. The conversion is 1 gram per milliliter. And then C, which you can think of as the specific heat, 1 calorie per gram times temperature, and then you cancel temperature with the change in temperature, 50 degrees Celsius. All these cancel out, temperature, temperature, grams, grams, milliliters, milliliters, and you're left with calories. Who cares about what that is, but you're left with calories. Then the delta H fusion, in which there's no change in temperature. You don't have to do anything with temperature in this one. You have the same amount of gas, milliliters, and then you have to convert that to grams again, 1 gram per milliliter times a specific heat, which is different in this case because you're not changing the temperature, you're just changing the state. It's given to you already on the front of the page, and it's 80 calories per gram. Now the only thing I'm not really sure about with this step is that the density of ice is less than the density of water. So here, when I'm converting the milliliters to grams, and here in the next step when I'm converting the same thing, I'm not sure if that's right. But I think I'm going to end up with calories, which is the correct unit to end with. The last step is to figure out how much kinetic energy you get when you decrease the energy of the solid, when you freeze the ice even more. That again is 500 milliliters times grams over milliliters times calories over grams times temperature. And the change in temperature is 25 degrees because you're going from 0 degrees down to negative 25 degrees. That is the change in temperature. Everything that you're doing in this problem is finding out the x values. When you finish the entire thing, you'll know exactly how much energy it takes to go from here to here, which ends up being one number. You add up all these three things and you get one number, which is the amount of energy that you've lost going from this point to this point. It's like the change in x, even though you already know the change in y. Thank you for listening. I hope this made it clear for some people and hope we can do better in class. Thanks again. Good luck.